Imagine you have just 1 kilogram of matter. According to Einstein's famous equation, that tiny amount of mass is equivalent to an astonishing amount of energy. But here's the strange part. Why does multiplying mass by the speed of light squared give us energy? And what does the speed of light have to do with matter? Let's find out what Einstein actually discovered. What does E equals to mc squared mean? Let's start with the equation. E equals 2 mc squared. E represents energy, m represents mass, and c represents the speed of light. But there's an important detail. Einstein wasn't simply saying mass can magically turn into energy. The deeper idea is that mass itself represents energy. Even an object sitting completely still has energy because it has mass. This is called rest energy. And that rest energy is given by E equals to mc squared. This is where the equation gets really interesting. Why does the speed of light appear in an equation about mass and energy? The answer comes from Einstein's theory of special relativity. Relativity showed that mass, energy, and motion are deeply connected. Even when an object isn't moving, it still has energy simply because it has mass. And the conversion factor connecting that mass to its rest energy is c squared. So the equation is telling us something profound. Mass represents an enormous amount of energy, even when the object is completely at rest. So what does c squared actually do? Now let's take 1 kilogram of mass. The speed of light is approximately 300 million meters per second. But Einstein's equation doesn't use just c. It uses c2. So we're multiplying 300 million x 300 million. That gives us 90 quadrillion, or 9 to 916. Now multiply that by just 1 kilogram. You get approximately 9x and 16 joules of energy. That's 90 quadrillion joules. And this enormous number is the reason a tiny amount of mass can correspond to such a huge amount of energy. But why can't we just turn 1 kilogram into energy? So you might be thinking, if 1 kilogram of matter represents this much energy, why don't we simply convert it all into energy? This is where E equal to mc squared is often misunderstood. The equation tells us about the equivalence between mass and energy. It doesn't mean that converting ordinary matter completely into energy is easy. In fact, doing that is extremely difficult. But nature does have ways to convert small amounts of mass into energy. How does nature release this energy? This happens in nuclear reactions. Imagine starting with several particles whose combined mass is slightly larger than the mass of the particles produced after the reaction. So where did that missing mass go? It didn't simply disappear. That difference in mass corresponds to energy. And because that difference is multiplied by c squared, even a tiny change in mass can produce a huge amount of energy. This is the basic principle behind nuclear energy and nuclear fission. So you don't need to convert an entire kilogram of matter into energy. Even a tiny mass difference can release an enormous amount of energy. So let's simplify everything. E equal to mc squared doesn't mean matter is a magical battery. It tells us that mass and energy are deeply connected. Mass represents a huge amount of energy because the conversion factor is the speed of light squared. And that leads to an even bigger question. How does nuclear fission actually release that energy from such a tiny change in mass? That's where the story gets even more interesting. And we'll break that down in the next video.